Welcome back to Forge College. In our last lesson, we talked about how to find data on the blockchain. Today, we are looking at how we actually update that record, the process of making a secure change to the ledger. To update the blockchain, you submit a transaction. Think of this as an instruction to change the shared record of who owns what. It moves funds or triggers a contract. As you can see, getting that instruction approved is a strict process. We have a robotic bouncer standing guard at the doors, scanning every single request for errors. That bouncer is the Ethereum node. The node acts like an incredibly picky door person, and your transaction is a VIP ticket trying to get into the blockchain. If your ticket is missing a single detail, you are not getting through those doors. The bouncer checks 4 main things on this ticket: who is sending it, who is receiving it, how much digital currency is being moved, and any specific instructions or data for a smart contract. Without these uncompromising checks at the door, the entire record of balances would fall into chaos. People could try to spend the same money twice or make changes they aren't authorized to make. Let's look at how the bouncer evaluates your ticket. Step 1 is a basic layout check. The node looks at the transaction to see if it is readable and organized correctly. If the data is messy or the envelope is the wrong size, the node tosses it out before doing any hard work. If the request is readable, we move to the ID check. The transaction carries a digital signature split into 3 specific parts, which the experts call V, R, and S. This diagram shows how those parts work. The bits of the signature are fed into a math-based funnel. The result of that math is the exact verified public address of the person who sent it. It is a mathematical proof that the ticket is real. Verifying this signature happens first because it's a quick way to spot a fake. If the math doesn't add up, the node rejects the fraud immediately, saving its energy for legitimate users. Once the bouncer knows who you are, it checks your place in line using a sequential ticket number. In the blockchain world, this number is called a nonce. It ensures every action from your account happens in a specific, one after the other order. Ethereum requires an exact match. If the records show your account just finished transaction number 6, the bouncer expects the very next ticket to be exactly number 7. As you can see on the belt, when ticket 7 arrives, it slides perfectly into place. This numbering keeps you safe from replay attacks. If someone tries to send a copy of an old payment, like ticket number 6, the bouncer sees the number has already been used and rejects it instantly. If a ticket shows up too early, like number 8 arriving before number 7, it gets sent to a waiting area. It stays there, unable to move forward, until the missing number 7 shows up to fill the gap in the sequence. This sequential numbering ensures your transactions happen in the exact order you intended, making it impossible for someone to mix up your history or double spend your funds. Our bouncer has verified your ID and your place in line. Now for step 4, the cover charge. The node checks your balance to make sure you can afford the minimum fee to use the network. This scale shows the calculation. The node weighs your total funds against 2 things: the amount you are sending and the maximum possible fee, or gas, the transaction might use. You must have enough to cover both before the bouncer lets you in. If you can pay, you enter the mempool. This is a digital waiting room where verified transactions sit until a block proposer picks their book to be officially added to the chain. This step-by-step pipeline ensures nodes only process authorized instructions in the right order and fully paid for. To see why Ethereum works this way, we have to look at the difference between 2 ways of tracking money: the bill method and the ledger method. Bitcoin uses the bill method. Spending $20 shatters a $100 block, creating 2 new pieces, 20 for the recipient, 80 in change. Ethereum uses the ledger method. Nothing is destroyed. The system simply erases your old balance and writes the new one. Because Ethereum updates the same record over and over, that sequential ticket number we talked about, the nonce, is vital. It's the only way the bouncer knows which update to the chalkboard comes first. Finally, we reach execution. A block proposer pulls your transaction from the waiting room, and the network's central computer officially runs your instructions. This is where the record finally changes. Your balance goes down, the recipient's goes up, your ticket number moves up, and the change is permanently saved to the blockchain. Check the layout, verify the ID, confirm the ticket number, and pay the fee. That careful process is how a simple request becomes a permanent, secure change to the world computer. Thank you for joining us at Forge College. This process is a foundational part of how the Ethereum architecture works. To keep learning about the fundamentals of Web3, head over to forge.college to continue the track. See you in the next lesson.